My dear students, today we will discuss few more concepts related to signal systems. Since November 5th onwards, you are having the first internal test, first CI test on signal system, and our sir has informed us that up to first internal we have to complete at least two modules, that is first module and second module. But since time is less, we can't complete two modules within a limited span of time. Therefore I am doing this video lecture, because since we are discussing first module only, still we have to discuss few more concepts which are there in the first module. Therefore what I have decided that I will make that is video lectures on second module, so that we can complete two modules for first internal, that is within 5th November we have to complete two modules, because common question paper will be there, and also we have to complete two modules for the first internal. Therefore today I am doing video lectures related to second module. That is, second module is nothing but it is related to, that is linear time invariant systems. Linear time invariant systems means, already you know that system is what? Nothing which will take one form of signal and convert into other form of signal is known as system. For example, television system, which will take the signal in the form of electrical, and it will convert into the audio, video, the data, the text, whatever that signal, that it is nothing but it is converting, it will taking the signal in the form of electrical and converting into voice, that's video, audio, some text. That is nothing but television is a system. Here in first module we will discuss about what is system and what are the properties of the system. That is, so many properties of the system. Time invariant property, time variant property. In first module we will discuss about so many properties of system. Time invariant property, time variant property. For example, bus arrival and departure is an example of time invariant system, because it will and train arrival and departure. For example, if it comes by 5 minutes late, it will departure 5 minutes late. That is, as there is change with respect to time, that is nothing but time invariant systems. Here they have given in first module, while when we discuss about time invariant systems, at that time we'll come to know what is time variant and time invariant system. That is, here they have given, that is what are time invariant systems. Here time variant and time invariant and time variant systems. In time invariant means definition: a continuous time system is a time invariant if the time shift in the input signal results in the corresponding time shift in the output. That is, for example, they have given so many example of time invariant and variants. For example, bus and train arrival and departures, it is time invariant. Rainfall per month, it is time variant, because we can't predict that at particular time, particular instant the rainfall will happen. No, anytime it will come and any time it will go. Therefore it is time variant. Thermal noise in electronic components, it is also time variant. And noise effects, this is also time invariant. File handling in C language, it is time invariant. Printing documents by the, suppose we want to print 100 pages, then it is time invariant. Why? Because as we give the input, according to that we will get the output. These are some examples of time invariant and variant system. Similarly, what is linear system? Linear definition: a system is said to be linear if it satisfies the superposition principle. That is, it is linear means suppose as there is an increase in time. Suppose similarly the change linearly if the amplitude varies, the current varies, then such systems are called as time linear systems. Linear means some exponential signals. Those are not linear signals. Why? As there is increase in the signal, correspondingly there is not increase in the signal. There may be a rapid increase in the signal. Such systems are called as non-linear systems. As there is increase in the time, similarly there is increase in the amplitude or time, amplitude in current or something, then those systems are called linear system. Therefore, today we'll in second module we will discuss about linear and time invariant LTS. These systems are called as LTS system. The system should be linear and also it is time invariant. Here they are given introduction time domain representation for LTI system. LTI means linear time invariant. Time invariant means corresponding as there is change in the input, there should be corresponding change in the output. That systems are called as time invariant system. Linear means as increase in the time, there should be corresponding increase in the amplitude, increase in the current. Such systems are called as linear system. Then what do you mean by LTS system? Definition of LTS system: the system which is linear and time invariant is called linear time invariant system. A system which should be linear and at the same time it should be time invariant. Such systems are called as LTS systems. Most of the systems in the nature are LTS systems. The input and output of LTS systems are related by most of the systems are LTS systems. The input and output of the LTS systems are related by here how we can relate the input to the LTS system, how we can relate output of the LTS system. There are some following techniques are there. That is how we can relate the input and output of the LTS system. That is convolution integral. Convolution integral for CT systems. CT, that CT system is continuous time system. Continuous times system. Convolution sum for DT signals. Discrete time systems. Continuous time systems, discrete time system, convolution sum for DT, convolution integral for CT system. Then we'll discuss about impulse response of LTS systems, difference and difference equation to find out what is the relation between the input and output of LTS systems. Therefore, we will discuss one by one. First, we will discuss about what is convolution integral and how we can obtain the input and output response of a LTS system. Important in exam, definitely they will ask some problems related to convolution. Definitely they will ask related to convolution integral, related to convolution sum. That questions they may ask for 10 marks to 15 marks like that. The problems are also lengthy. You have to follow so many steps to find out the results of these convolution integral systems. The result for the solution for convolution integral. Several convolution sum is there, impulse response is there, difference and differential equations are there. All these concepts we'll discuss one by one. First, we'll discuss about the convolution integral. This convolution integral it is used to find out the input and output response of the LTS system. Convolution integral. The convolution integral relates here you see the convolution integral relates input output and unit impulse response of the continuous systems. Continuous system unit response, that is convolution integral relates input and output and unit impulse response of the continuous time system. Here to calculate the output and to relate the LTS system, the input and output of that input and output to the input and output of LTS systems are related while getting the relationship between the input and output of the LTI systems. Here in convolution integral we have to use the unit impulse response. Unit impulse, already in the first module we have discussed about the so many different types of signals. In that we have discussed about unit step function, unit step signal, unit impulse function. That is nothing but what is the unit impulse function or unit impulse signal. That is means the impulse, the signal existed at the time interval t equal to 0, and it will not exist when t is not equal to 0. The signal will not exist at a particular instant of time. The signal exists at t is equal to 0. That is nothing but unit impulse function. Also we have discussed unit step function, unit step signal. Means when t equal to greater than or equal to 0, the signal exists. That is unit step signal. Here unit impulse means only at the particular instant. At particular instant means t is equal to 0. That instant only the signal exists, and apart from this the signal will not exist when t is not equal to 0. Therefore in convolution integral we have to use the concept of impulse function. Here they have given how we have to derive for unit impulse function. Then next some derivation for convolution integral is there, and everything is there in the notes. You refer within 3-4 days I will provide you the notes related to this signal system. I have made notes of referring 3-4 books, made notes on this signal system. These are very important concepts which are there in this in the notes. I will provide you the notes. You after 2-3 days you take the xerox of these notes. Here I will discuss only 1 or 2 problems, but in the book I have made solution of 8 to 10 problems related to convolution integral, 8 to 10 problems related to convolution sum. Therefore you go through the notes, you will come to know how so many different problems will be asked related to convolution integral. So many problems how they will ask to related to convolution sum. Here I will discuss only 1 or 2 problems for to understand the convolution integral. Here this is the equation to find out. This is the equation here. Y of t equal to integration of minus infinity to plus infinity x of tau h t minus tau d tau is to find out this equation relates the impulse in response to the output. The output yt is equal to convolution of x of t and ht. Hence the above equation is called convolution integral. That is convolution integral equal to y of t, that is equal to integration of minus infinity to plus infinity x of tau h of t minus tau d tau. This is the equation to calculate what? Convolution integral. Here suppose this is an LTI system. Suppose input is I will treat as dou t output that is h of t. For that we have to find out what its unit what is its convolution integral. This is the equation to calculate the convolution integral. With an example I will explain how we will get the convolution integral. Here you see here the convolution of above equation can also be represented symbolically as y of t equal to x of t multiplied by h of t. X of t into h of t equal to, that is integration of minus infinity to x of tau h of t minus tau d tau. This is we got from the derivation. Here we have the derivation. Since time is less and not discussed how we have got this equation to calculate the convolution integral. Okay, with an example we'll come to know how we have to solve the example related to convolution integral. We'll discuss with a problem. One problem we'll discuss related to convolution integral. Here the impulse response of the LTI system is h of t equal to u of t, means h of t, that is unit impulse response, it is impulse response is called is h of t equal, determine the output of the system if input x of t, input is what, x of t equal to e raised to minus at u of t, then find out when a is greater than 0, then find out what is y of t. Impulse, they have given the impulse response, they have given x of t. How we can obtain the that y of t? Y of t is nothing but x of t into h of t, that is x of t into h of t is equal to minus integration of minus into plus infinity x of tau h t minus tau d tau. This is what, this is nothing but convolution integral. Convolution integral y of t equal to integration of minus infinity plus infinity x of tau h t minus tau d tau. Here, now we will solve this problem. We'll find out what is y of t. The given function r, impulse response is ht equal to ut, that is unit step function. Then input is x of t equal to e raised to minus at ut. When a is greater than 0, in this condition a should, when it is a is greater than 0, then figure shows the plots of x of tau and h of tau. Then output of the system will be equal to convolution of x of tau and h of tau. The output of this will be, then we'll find out first, we will solve for different cases. That is y of tau equal to x of t into h of t. That is nothing but integration of minus infinity to plus infinity x of tau h of t minus tau d tau. Case 1, when in case 1, suppose we will take t is equal to 0. When t is equal to 0, this is your x of tau, x of tau, x of t, then we treat it as x of tau, then e raised to a minus a of a tau, that is this at is there now, that we will discuss, this we will treat as x of t equal to e raised to minus at is there, then we think we will treat as that is x of tau equal to e raised to a tau, and u of t is nothing but it is unit step function, it is value is 1, need not to consider that one. Then this equation, this equation represents the exponential decaying signal, exponentially decaying signal with the starting value as 1, that is this equation represents this signal. That is, now let us determine, hence putting the value of t equal to 0 in the above equation, this is what your signal e raised to minus at, e raised to minus at into u of t, that represents this signal. Then h of t equal to u tau, ut means what, unit step signal, this is ut, this is a unit impulse response, that is at that time when we call as response, then we have to consider this as h of tau, that will be equal to u of tau. That is, therefore it is unit step function. We know that unit step function is value is 1 and it exists when t equal to 0 or t is greater than or equal to 0. Therefore this is the signal. Then case 1, when we will consider the different cases. Case 1 is when t is equal to 0, when t is equal to 0, therefore y of is equal to 0, then integration of minus into plus infinity x of tau h of minus tau. Why minus tau? Here in the above equation we have taken this as t equal to 0, therefore when we consider this t equal to 0, then this equation becomes y equal to minus infinity to minus into plus infinity x of tau h of minus tau. H of minus tau means what? This is unit step, that we have to, this is what h of, that is folding operation. Already we have discussed about so many the operations which we do on the signals. What are those? That is compression, expansion, that is time folding, time shifting, These are the operations, so many operations. Folding here, minus term means what? Folding. Here you see, folding means to take the mirror image of this. If it is this side, we have to take this side. This is h of tau, h of minus tau. There is no change because x of tau as it is, but in this we have to take h of minus tau. This is h of tau. This will be, but we want what? H of minus tau. H of minus tau is this. Therefore, consider these two signals. These two, when we see these two signals, there is no overlap of this signal. Therefore, the net value of this equation y of y equal, this is because this is existing towards the positive value of time axis, the above signal, but it is existing towards the negative value of time axis. There is no overlapping of the signal. Therefore, the result is 0. That is, here you see this product is always 0 since the two waveforms does not overlap. Therefore, this product is value is 0. Now we will consider when the case 2. In case 2, we will consider t is greater than 0. When t is greater than 0, what happens? Now let us consider that t is greater than 0. Then as per equation, y of t will be, that is y of t equal to integration minus into plus infinity x of tau h t minus tau d tau when t is greater than 0. When you take greater than 0, we know that x of tau equal to e raised to minus t. This is nothing but the signal. This equation represents this is signal. And here also h of t minus tau, this is the signal. This when we take this h of tau units of function, but when we this is what? This is your h of t minus tau. H of t minus tau. This is this is folding. In that folding, that is it is that when we take this is h of minus tau, but this is what? H of t minus tau. At that time, the signal becomes like this. Then when we see these two signals, then this region here, this region and this region will overlap here up to this region is this signal overlaps with this signal. Therefore, here we will get what is y of t equal to we'll modify this equation, and it becomes, this equation will be y of t equal to 0 to t x of tau h of t minus tau d tau for t greater than 0. Then from this here there from figure it is clear that h of t minus tau u of t minus tau 1 from 0 to 0 to t. Hence our equation becomes y of t equal to 0 integration of 0 to t e raised to minus at and into 1. Why? Because here h of t minus tau is the amplitude is 1. This is since it is unit step function 1. Therefore d of tau equal to d of tau. Then integration of 0 to t e raised to minus at dt 1. This 1 we will consider anything multiplied by 1 is same as it is. Therefore we will get. Then when we apply the integration, when we apply the limits, when we do the integration of this, the value we get value of this, and apply the limits 0 t. When we apply the limits, we will get the equation y of t equal to 1 by a into 1 minus e raised to minus at for when t is greater than 0. When t is greater. Case 2, this is how we will get the value for when t is equal to greater than 0. Now we will take another case, that is when case 3, that is t is less than 0. First what we had done, we have taken t is equal to 0, we will get the what equation we will get. When t is greater than 0, what is the equation? So now we will consider when t is less than 0. When t is less than 0, this is the equation to calculate the convolution integral, that is minus infinity to integration of minus infinity plus infinity x of tau h of t minus tau d tau when t is less than 0. When t is less than 0, this is your x of t e raised to minus at. Then h of t minus tau. h of t minus tau, this equation becomes, the signal becomes like this. This is your h of t minus tau. This is h of t minus tau for t less than 0. T less than 0 will get this signal like this. Here also, when we see, this is for t less than 0. Therefore, when we see these two signals, then there is no overlap of the signal. Therefore, the output of the signal is 0. If it is overlapping, we'll get some equation. But here you see that is t less than 0 shifted. The product of x of tau and h of tau will be 0. Why? There is no overlapping. You see this is existing this side towards the positive axis. This is existing towards negative axis. There is no overlapping of these signals. Therefore, the product, the output of this this signal, convolution integral is 0. Y of t is 0 for t is less than 0. Therefore, result is what? Thus, we obtained the output y of t as y of t is equal to y of 1 by a equal to 1 minus e raised to minus at for t greater than or equal to 0. When t is greater than 0, we'll get this one. When t is equal to y of t is 0 for t less than 0. Here we have to write when t is equal to 0. Here I think little modification. Here t is greater than 0. I think here we have taken this is t greater than 0. We got this equation. T equal to 0. T is equal to 0. Yes, when t is equal to 0, we got this is 0. Therefore, this is equation will be, this is correct, but here we have to write t is equal to 0 for t is equal to 0. This is the equation. For thus we obtained the output y of t as y of t is equal to 0 for t is equal to 0, and it is equal to 1 by a into 1 minus e raised to minus at for t greater than 0, and it is 0 for t less than 0. This is 3 equation. We got the result of the convolution integral when we draw the waveform of this equation. This is the result of convolution of x of t and h of t. Why it is plotted like this? When we plot according to this equation, we'll get such waveform. This is nothing but result of convolution integral. Okay. In next video lecture, we will discuss few more concepts, few more problems related to convolution integral. Okay. Thank you.